Okay, so the agenda of this video is that we are solving indices questions. Previously in these videos, I have detailed the theory of indices. I have done 1, 2, 3, these 3 questions also. I'll be doing question number 4 and question number 5 and question number 6 in this video. All these questions have been taken from Selina 2020 edition, which is a textbook for ICSE. It is exercise 7A. But even if you are not a ICSE student, say you are a CBSE student, or you are preparing for a competition, maybe for SAT or Olympiad or maybe any MBA competition, this video is good for you because the quality of problems is excellent. The quality of problems that we have done is excellent. Let's start. So the first question is 3 raised to power minus 4 upon 2 raised to power minus 8 whole raised to power 1 by 4. Okay, note this question down. You can start on your own, or you can wait for me to tell you how to solve this question. Okay. One basic law that we need to understand is that a raised to power minus m is equal to 1 upon a raised to power m. What does this mean? This means 2 raised to power minus 3 is equal to 1 upon 2 cube. This is a powerful, basic, fundamental rule of indices. So what I can do is I can write this 3 raised to power minus 4 as 1 upon 3 raised to power 4, and I can write this 2 raised to power minus 8 as 1 upon 2 raised to power 8. I hope you are able to see how I am able to do this. And I can write this as 2 raised to power 8 upon 3 raised to power 4, and this 1 by 4 is waiting outside. Now this 1 by 4 will multiply by this 8 as well as this 4 when it comes inside. So this will be equal to 2 raised to power 8 into 1 by 4 upon 3 raised to power 4 into 1 by 4. So this will cancel. So the final answer would be 2 square upon 3 is equal to 9 upon 3. You should be well aware of the rules of indices. If you have any doubt on the rules of indices, I'll request you to have a look at lecture number 1 of this series. We had discussed in detail all these rules with examples. It's an excellent lecture. Please have a look at that. So a raised to power m into a raised to power n is equal to a raised to power m plus n. M upon n is m minus n. M whole n is m into n. So we had discussed these rules in the first lecture of this series. And indices gets very important because unless and until you are very clear about the rules of indices, you won't be able to do logarithms. You won't be able to do logarithms. I have a playlist of logarithm also. My channel partner is equal to Shivang also has done a lot of videos on logarithms. You can have a look at those playlist of logarithms also. Let's move to the next question. So if you understand the logic, again what I'll be doing is I'll be taking reciprocal of this. I'll be taking reciprocal of this. 27 I'll write as 3 cube. This I'll write as 3 square, and I'll be multiplying. So you can start the question, you can pause the video, or you can see how I solve this. Okay, let's move to the other screen. Okay, so 27 I can write as 3 cube. There is a minus 3 outside. 9 I can write as 3 square, and there is a minus 3 outside, and there is a 1 by 5 which is looking at everything inside. Okay, this I can write as 3 raised to power minus 9. This I can write as 3 raised to power minus 6, and the 1 by 5 looking inside at everything. Okay, so this is equal to minus 6. This minus 6 will come up and become plus, and 1 by 5. This is equal to 3 raised to power minus 3, 1 by 5. This is equal to 3 raised to power minus 3 by 5. This is the final answer. Let's move to the next question. Okay, so the next question is 32 raised to power minus 2 by 5 divide by 125 raised to power minus 2 by 3. Again, this 32 would be equal to 2 raised to power 5. This would be 2 raised to power 5. This whole will get multiplied by minus 2 by 5. Then we have this divide. I can write this as 5 cube, and this minus 2 by 3 would be here. Minus 2 by 3 would be here. And then I can simplify. You can note this question down. You can start your question, or you can follow me on the next screen to see what happens next. Okay, let's move to the other screen. Okay, in the first question, on the first question, there is a small error that I have made. I think you would have noticed this error. This is the error. This should be 4 by 3. Please excuse for this error. Okay, so as we were discussing, this would be equal to 2 raised to power 5 minus 2 by 5 whole upon 5 cube whole raised to power minus 2 by 3. Now what I'll do is I'll multiply this and this. 5 with minus 2 by 5. 5 with minus 2 by 5. I'll write this as 3 into minus 2 by 3. I'll cancel this. I'll get 2 raised to power minus 2. When I cancel this, I'll get 5 raised to power minus 2. This I can write 1 upon 2 square. This negative will make the reciprocal. So this will be equal to 1 upon 5 square. So the final answer would be 25 by 4. See, these indices get difficult for a lot of students that I meet. So I'm advising you again and again that before you can not do these questions unless and until you are very comfortable with these rules. And because I've already spent time in detailing these rules, that is why I'm avoiding spending more time in this video. I'll request you again to have a look at the first video in this playlist. You will get a lot of understanding if you are not clear. Okay. So this question seems to be a bit confusing, but we'll see this part by part. What you need to understand is that this is the first bracket that we'll be opening. Then we'll be opening this bracket, curly bracket, and finally we'll be opening this bracket. So what I'm trying to tell you is, when you try to do these type of questions, what you need to remember is tackle this first, then this, and then this. You have to go from inside to outside, not from outside to inside. That is not how you can do these questions. Beautiful question. You can note it down, try to do it, pause the video, or you can follow me when I do this video or when I do this question. Okay. So I'll start from here. I'll write this as 1 minus 1 upon 1 minus n. This curly bracket comes. There is a minus 1 outside. 1 minus. So this type of question can easily come in competitions. This or any other similar question can easily come in competitions. It can come in Olympiads. It can come in some MBA entrance. They can easily come. Okay. So what do we do next? First thing that we need to do is take a LCM of this. So take a LCM of this. Okay. So what I do is I need to take the LCM of this 1 minus 1 upon n. So this question is a bit complicated, so that is why I took the liberty of doing some few steps more so that I can make you understand. So 1 minus 1 upon n. So have a look at this. Have a look at this. 1 minus n would be the LCM. So this would be 1 minus n minus 1. This is 1 minus n. 1 minus n minus 1. So this 1 and this 1 gets cancelled. I am left with minus n. This is the minus n upon 1 minus n. There is a minus 1 waiting outside. This is the curly bracket that we have got. 1 minus this curly bracket. And this curly bracket also has a minus 1 outside. And then there's this big solid bracket with a minus 1 outside. Yeah. Now what I do is, because there is a minus 1 outside, I take a reciprocal of whatever is inside. I hope you get this. And what I do is 1 minus n, this 1 minus n would go to the numerator. This minus n comes to the denominator. This minus 1 vanishes. This minus 1 has vanished. There is a minus 1, there is a 1 and the solid bracket outside, and there is a minus 1 still waiting outside. Okay. Now what I have done is I have taken this negative and I have cancelled this negative. I have cancelled this negative with this negative and this positive. So what I've done is I've basically made this 1 minus n as n minus 1 upon n. 1 minus is still outside and this minus 1 is still outside. So this is 1 minus n minus 1 upon n. Now I need to take a LCM of this 1 minus n minus 1 upon n. I hope you are following this. Okay. So when we take a reciprocal, when we take the LCM of this term inside the bracket, there is a minus 1 waiting outside. I've written the minus 1. Now, how do I take the LCM? This is the LCM. I've taken the LCM as n. So n multiplied by 1 is n. There is a minus n and plus 1. So this is minus n and plus 1. Now n minus n would cancel. This is 1 upon n. There is a minus 1 outside. And I need to take a reciprocal of 1 by n. So my final answer would be n. This is a bit complicated question. You may like to rewind and see this question again. Okay, next question. If 2160 is equal to 2 raised to a, 3 raised to b, 5 raised to c, find a, b and c. See, these questions are simple. All you need to do is you need to do a prime factorization of 2160. I hope you know how to do prime factorization of 2160. So when you do the prime factorization, the answer would look something like 2 raised to power something, 3 raised to power something, 5 raised to power something, and those you need to match this with A, B, C, and that will be the final answer. So what I'm trying to tell you is, note down this question, try to do it, and this is what I'm trying to tell you. That 2160, if I take a prime factorization, I can write 2160 as 2 raised to power 1, 2, 3, 4. 3 raised to power 1, 2, 3. And 5 raised to power 1. Now when I compare these two, it is clear that A is equal to 4, B is equal to 3, C is equal to 1. This is the final answer. This is the final answer. Let's do the next question, which is similar to this question. If 1960 is equal to 2 raised to A, 5 raised to B, 7 raised to C, find A, B, C. Again, I'll need to take the prime factorization of 1960. when I do the prime factorization, it should be obvious that it would be equal to 2 raised to power something and 5 raised to power something and 7 raised to power something. Those somethings need to be compared to this, and I'll have the answer. So this is how you do it. So 1960 can be written as 2 cube 5 raised to power 1. This should be equal to 5 raised to power b. I think I've made a mistake here. This should be 5 raised to power b. I'll check whether I have made the same mistake here or not. No, here it is fine. So this should be 5 raised to power 1 and 7 raised to power 2. When I compare, A is 3, B is 1, C is 2. Okay, that brings us to the end of this video. In the next videos, I'll be doing indices equations. Indices equations. Now the indices equations, this is how they look like. 2x plus 1 is equal to 8. So find x. You have to solve for x. This is what I'll be doing in the next videos. Indices equations. If you want to do rest of questions from this exercise, if you are ICSE student and you want to do the rest of questions from exercise 7a, I'll request you to have a look at isequaltoklasses Shivan. He is my channel partner. He has done a lot of videos on logs, trigonometry, circles, stoichiometry, geometry also. You can have a look at those videos also. Basically, he does questions from Selina textbook, ICSE board. Please have a look at his channel also. Thanks for watching this video. Thanks for your time. I hope this video was useful for you. We'll meet next time when we'll do the indices equations, how to solve indices equations. Thanks a lot.